Okay, hello everyone. Welcome to another episode of Q&A about business, innovation, and managing life. And I see there are a few questions that got submitted on our form and some others that are stored up from last week, but I'm happy to, or 2 weeks ago, but I'm happy to try to address any questions about those topics. It's my effort to both think things through for myself as I try and explain it to you all, and perhaps to provide some useful input for other people. Let's see, we have a question here from JAL. If I could live anywhere in the world, where would it be? Any business or scientific reason why that place? Well, I will say that I do in fact live in a suburb of Boston, Concord, Massachusetts, and I've lived here for a bit more than 20 years now. And I have been a remote CEO since 1991, 31 years now. And originally, when I had started my company in 1986, 1987, for a while, I was very much a in the office kind of, well, mostly in the office kind of CEO. I think then I realized, well, in 1991, I was in this situation of having a company with 50, 100 people, something like that, and injecting ideas at a higher rate than we could possibly absorb. And so I decided to kind of throttle back on my CEOing and idea injection activities and instead concentrate on doing basic science for what I thought would be 18 months or so. And that time moved to California where I stayed for about 18 months, and then moved to the Chicago area. And the year and a half of working on basic science stretched into more than 10 years and led to my big book, A New Kind of Science. I basically ended up discovering much more than I expected to discover. And during that time, I kind of had a throttled back approach to sort of CEOing the company, which then became more intense after that. But I kind of set the idea of being a remote CEO back 31 years ago. And so that meant that I could kind of live anywhere. The theory was, so I had different theories. Like for a while it was like California. Okay, that's a place where I know people and there's kind of a whole tech scene there. I ended up interacting with that tech scene essentially not at all while I was there. I was basically just working on my science book, and I was like, well, I don't know, I can't really be bothered to drive over the bay, so to speak, and go interact with people. I'm just going to keep working on my science book. And then our company headquarters is in Champaign, Illinois, which is about 100 and something miles south of Chicago. And when I was there, it was like, oh, I'll go down there frequently because it's an easy drive. But in fact, I found myself going down there almost not at all, and being really a remote CEO because it was much easier to just do things remotely. And we had an increasing number of kind of geo-distributed employees at that time, and now it's even more. So again, I was kind of just being where I was. And at that time, I was really, that was the period 1993 to 2002, I was really intensely working on my science project. And with the exception of about a year, when we brought out version 3 of Wolfram Language and Mathematica, I was really pretty hermit-like, working, on this and really not interacting with my local environment. I could have been living absolutely anywhere. It wouldn't have made any difference. Then in probably around 1999, 2000, I was kind of thinking, well, we could kind of live anywhere. And my wife and I kind of investigated where should we live? And the kind of the calculation was, okay, let's just look at the address lists and so on. Where in the world do we know the largest number of people? And the answer was Boston by a decent margin. I think San Francisco was number 2 for our pooled kind of address lists. London was number 3. And then a bunch of other places are, and then New York was somewhere in that picture. And then the question was, given that, it was like, okay, let's try and find a plot of land we can get that's reasonably close to the city, but it's decently large, and we can build a house there and sort of lead a peaceful life type thing. And what I didn't realize, because Wolfram Alpha didn't exist at the time, is how much larger Chicago is than Boston. And it was sort of a surprise that the distance you had to go out from the center of Chicago to be able to buy a reasonable size, a largish plot of land was much larger than the distance you had to go out from Boston to do the same thing. And the prices were correspondingly higher within a given radius, et cetera, et cetera, et cetera. And so that was part of the reason for sort of, which might have been a different decision if I'd been able to look at more socioeconomic data, sort of Wolfram Alpha style socioeconomic data back in 1999 or 2000. But the surprising thing is that I've lived in the Boston area now more than 20 years. I think it took about 10 years for people in the local area, who were relevant to the kinds of things I do, to even know that I was in the area type thing. Probably if it was a smaller sort of community or whatever, that would be more immediately more obvious, so to speak, if one was kind of, oh, there are these people one should interact with. And maybe for me personally, I have enough diversity of interests that it's not like, oh, if the physicists know I'm here, then everybody I care about knows I'm here. It's lots of different communities, and that takes a lot longer to have happen. But I think this question of sort of where one is, and my attitude tends to be that if one is in a place, so for example, another thing that I notice is I get invited to all kinds of events and so on, and there's a question of, well, where are those events, and where are the sort of clusters of those things? And for me, it's I'm perfectly happy to sort of interact with people, although I also work hard on the things that don't involve interacting with people, or interacting in person, at least with people. So if there are events that are kind of that I'm interested in that are within easy driving distance, that's kind of a win. And what I've noticed is that, yes, it is true that there are a lot of events and the kinds of things that I'm interested in that have traditionally been in Boston, although obviously last couple of years there've been almost no events at all anywhere. I would say that at any given time, as my interests have changed, sort of and as the world has changed, the sort of place where there are events that sort of are kind of my type of intellectual, techie, whatever events, has moved around a bit, though Boston is still a fairly good place for that. And I think it's kind of, as I say, the list of places that I gave before that are, San Francisco, New York, London, these kinds of things, those remain sort of even after all these years, those sort of remain the top places for the people and events that are relevant to the things that I'm generally interested in. Now, there are a lot of detailed personal optimizations that one might have about where one lives. I mean, for me personally, I tend to like to, I think, lead sort of the quiet life in some sense, and so I don't want to be or need to be in the middle of a city where there's lots of ambient activity and so on. I could imagine different people have different preferences in this regard. I think it's also there's also the question of the kind of the ambient experience of kind of, well, in these times there are things like, are you in a place where people are wearing masks or not wearing masks? That's going to go away soon enough. But these kinds of things that can make one respond in some way to the people nearby. I personally don't care very much, so that doesn't make a difference really to me. But for some other people, that's an important. Are you around people who you think you believe in, or you say that's crazy, or whatever else? That can be more or less important. I would say that there are other considerations, like there's always what's the cost of living, and can you do what you want to do where you are, given what is it something where you will be able to get the sort of environment that you want with at a price that you can afford, so to speak? And I know for our company, because we were very early in the kind of geo-distributed employee type situation, that this is now going back 25, 30 years, we had taken the point of view that in the US, at least, different in other countries, we were sort of the base for our compensation models was, well, in that case, Champaign, Illinois, which is about the median cost of living for the US. At least it was at that time. And it's like, okay, but you can live anywhere. And so people would routinely kind of find these places that were really, for whatever reason, good fits for them, nice scenery, whatever, mountains, whatever it was that they wanted, but where, given that kind of concept of you can live anywhere, given that sort of compensation level, that led to people to live in probably different places than they would otherwise have lived. When there isn't really a constraint on the other than perhaps a financial one on where you live based on the work you're doing, that sort of leads to different places. And obviously it's a matter of personal preference. Does it? One thing I have noticed is that I think there's a certain, I find it pleasant to be around sort of nice scenery, although any given sort of spectacular view, like when we were in California, I considered getting a house that had a sort of spectacular view overlooking, out on, where you could see a bunch of ocean in the distance type thing. But I kind of realized, particularly those kind of more distant views of things, yes, it's great for the first few days, and then you kind of get used to it. And it's, I don't know to what extent that's, but somehow I like, personally, I like sort of the, maybe one is imprinted with the kind of the countryside that one grew up in. I grew up in England, and New England is at least somewhat like England in terms of countryside. And so that's a thing. But this question as we come out of this pandemic of where people will choose to live, it's an interesting question. And it's not obvious, and it's not obvious as cities become maybe less pleasant to be in the center of. I don't know, remains to be seen. As people, if people decide, that there are different constraints that have emerged as a result of general socioeconomic trends, and I'm not sure what that will lead to. I think that there's also this big question right now of, are people going to work in offices or not? At our company, for example, we have very beautiful office space in a number of places, and our headquarters is in Champaign, Illinois, and we have lovely office space there. And I would say it's deeply underutilized right now. And because we're a company where we know that we can do geo-distributed work, it makes no sense for us to say, look, everybody's got to come into the office just because we have nice office space. That doesn't really make sense. There are groups where there's no choice because it involves machinery and things like that. But there are groups where it has been believed that it's really important for sort of the spirit of the group, so to speak, for people to be together in person. I think that one of the lessons of the pandemic for managers of those groups is it turned out it wasn't quite as important as people thought. But it's also the case that there are people for whom working in office is just easier, better, more productive than working at home. There are also people who have now deeply nested at home and got good working environments there, who are like, why would I come into the office where I don't have as good a view, I don't have as nice an office chair, I haven't got all my setup with my whatever it is that I have in my sort of home environment. This is just a much more productive place to be. That's one point of view. The other point of view is, for some people, it's like, gosh, what am I really supposed to do today? if there are people around and it's a kind of a buzzing environment, there's kind of a notion of, yeah, I'm going to be part of getting things done. Whereas if you're just kind of sitting on your own in the blank room kind of thing, it's like, what the heck am I supposed to do here? For somebody like me, for example, I am, I suppose, a very self-motivated character who has a list of projects much longer than I can expect to do in my lifetime. And so it's something where it's not, I don't really have the issue of, oh gosh, I've got nothing, what am I going to do next type thing. I'm kind of, I need some external motivation to get something done. I typically don't have that issue. But I think that the calculation of sort of where people should live and where their families want to live and all this kind of thing, I mean, that's definitely something that I think will change. And depending on well, all sorts of, I mean, we've had at our company a small number of, I would say, nomadic people where it's like, well, which country are you in today type thing. Those typically are people at certain, earlier stages of life where they don't have a lot of kind of, oh, the kids are in school in a particular school, whatever. My own kids, I have 4 kids, and the 2 middle ones particularly ended up, well, they did either homeschooling and later they went to an online high school. And so they were actually rather keen on traveling around the world. And that's something that is very easy to do if you go to an online high school, even if maybe you have to get up at some weird time of day if you're on the opposite side of the earth. It's, that was an interesting kind of feature at that time that I think was sort of worked out well for everybody. But for many people, that's not, it's like kids are in school in a particular place, and that kind of ties you down to that place, so to speak. Anyway, a few thoughts about where people. I would say that I can definitely tell that there are people who feel comfortable either where they grew up or not where they grew up, or some completely different place. Or it's like, I've always wanted to be in the mountains and now I can be in mountains and that's good. I think these questions about my own kind of constraints and interests in where I am are perhaps not completely typical, but those are some thoughts about that topic. Let's see, there's a question here from Green Tech. The question is about university versus experience in programming and computer science. Which one is more valuable? It really depends, but I think there are what one might call trade programmers, so to speak. Programming as a trade, where it is a question of sort of the more experience you have, the better you're going to be at it. And it is the case, it used to be true when my company was young, 30-something years ago, computer science departments at universities were not teaching things that were relevant to people, for the most part, who were going to do trade programming, so to speak, software engineering as a profession. They were teaching things that were quite theoretical. They were teaching, compiler design, automata theory, things like that, things that I personally think are super interesting, but they're not that relevant to most kinds of practical software engineering. About 20 years ago, a lot of computer science departments kind of pivoted to providing much more trade school experience and much more sort of practical, learn to write actual programs type experience. Now, perhaps, unfortunately, it's a little bit of a strange situation because in computer science as such, it tends to be the case that, well, you learn to program in computer science school, so to speak, but what you program is, well, there's sort of there's a lot of sort of pseudo-theoretical programming, because it's not like you are doing programming as applied to the area of, I don't know, insurance, or as applied to the area of, I don't know, land management, or who knows what, some other kind of specific area. it tends to be programming for its own sake and, improve your ability in the trade of programming, so to speak. And I think that there is a limit to how far that manages to go at universities. I think that there are some sort of standard practices and standard ways to think about programming nowadays. Universities often teach almost sort of management-y type stuff of, how you programming groups and things. At least some universities teach that. That's on one side. On the more theoretical end, there is an increasing amount that's known in sort of theoretical computer science. And for some kinds of programming, that's worth knowing. For other kinds of programming, it doesn't matter very much. I have to say that those other kinds of programming where it doesn't matter very much, I think over the next, let's say, decade, are in serious risk of being automated away. I say risk, but in a sense, it allows greater productivity, but it also means that the people who are doing that kind of sort of trade programming are not, that's not going to be as useful. It's not, until kind of robotics changes very much, the construction trades are still going to be, it's still useful to have, carpenters and things like this, because that's not something that's going to be automated away. But when it comes to low-level programming, and let's write a piece of, detailed procedural code that's going to ingest this data and put up this user interface and so on, a lot of that stuff either has already been automated away or will be automated away. And will be at the point, this is part of our effort with Wolfram Language, is to make a computational language that talks about the world and that represents things at sort of the highest possible level, at a level close to the way that we think about things, rather than the level that computers happen to be able to manipulate those things directly. And in a sense, part of our goal is to automate as much as possible. And that's just part of the general trend of doing that automation, which means that sort of the low-level kind of detailed procedural programming type thing is just not a very good. That's a field that will get automated away. I think one of the things I found a bit ironic is a few years ago when there was a lot more kind of concern around sort of AI and the automation of things and the removal of jobs and so on. One of the things that people were saying was, machine learning, everybody should get into machine learning. Machine learning is what's going to automate everything else. And I knew, because we'd been doing machine learning and we'd been trying to automate machine learning. And I was realizing that the first, cohort of people at risk of being automated away were precisely the machine learning people, because we had learned, and we've increasingly done this, how to machine learn about machine learning, so to speak. So that it used to be the case that there was artisanal work done on, tweaking the hyperparameters of this and that, and a lot of kinds of things that we can now automate away, so to speak, by using machine learning to automate machine learning. But I think in general, well, I will make a few other comments. The best programmers I know, most of them did not go to programming school. And that's been true over the whole period of time that I've known about, that's like 40 years, more than 40 years now, that I've known about kind of programming kinds of things. Those people, they went to school, maybe they dropped out of school, maybe they didn't really do official school past high school or even before the end of that. But they were just doing programming, and they have a certain turn of mind that allows them to think in a very efficient computational way. I would say that when I look at, and I know lots of those people and have known lots of those people over the course of time, those, the best programmers usually didn't go to programming school. The people who went through and did their degree in computer science and so on, they're perfectly good programmers among those people, but they're also people who I would say are, yes, they were trained up to do this kind of programming, but it was through training, not through raw kind of bursting out ability, so to speak, to do these kinds of things. So, I would say that if the goal is to become sort of the best programmer, so to speak, it is going to programming school is not particularly, doesn't seem to me, at least in the outliers of very outstanding programmers, that's not what you're seeing. Now, it is the case that there are pieces of sort of theoretical computer science, mathematics, and so on, which if you really want to do amazing sort of things when it comes to sort of inventing new ideas, inventing new algorithms, things like that. Those are worth knowing, much more so than the extra practice in doing practical programming, which is much better to get by just having experience doing programming than it is to going to programming school. At least that's my point of view. And I think one of the things that can also happen is that people learn very specific ideas, very specific kinds of methodologies for writing code, these kinds of things. I don't know to what extent sort of software engineering has kind of reached a plateau where what you learn today will be good for going forward. I mean, there are many professions where you could say, if you're going to become a lawyer, for example, you could say, you could have gone to law school many years ago, and what you'll learn today, obviously there are specific areas where things have changed in, technology related law and so on, but fundamentally it's going to be the same kind of thing that you would learn over the course of probably several hundred years in that kind of field. And I don't think, software engineering is still in a state of change, so to speak. And certainly some details will be like, well, you learn them this year and everybody's very keen on teaching you language X or Y. And well, in a few years, nobody will care about that. And, people learn Pascal, people learn Python now, people will learn Java in the past. Each one of these things has a certain, certain curves that are determined by all sorts of different factors. I mean, I think I've been lucky enough to work on one language for 35 years that has a different idea. This computational language idea is a different idea from programming languages and probably has a higher inertia in the sense it takes longer to ramp up and it'll last longer because there's just more in it. And it's not the kind of thing where you say, well, there's another language which is just the same, except it has a few features that are nicer. It's a much sort of weightier kind of proposition. But I think that, of course, that has the upside that it's a long-term story. It has the downside that it takes longer to kind of build up its momentum and so on. And there's certainly much more of that should be happening in the world today. It's always disappointing to me to see the extent to which people will say, well, I can get by with doing these things and running very fast and, putting together all these libraries and this, that, and the other, when it's like, well, we built that stuff, a couple of decades ago, and it's just one line of code. And that would be a better way to solve the problem. But, to do that really well, there are things that are worth learning that are not things that are just, we've tried to do our best to make things as easy as possible. And I think we've been pretty successful at that. But it's kind of there's a certain computational way of thinking that is super valuable, but is the thing that is needed to really take good advantage of our computational language. Well, let's see. So I think I just want to say one more thing about the experience in programming versus computer science. The thing that is worth really emphasizing is, yes, there is trade programming. Yes, there is even computer science research and so on. But the real future is computational X for all X, is making every different field make use of the paradigm of computation. And that really isn't much a story about trade programming. Sometimes it is, sometimes that's needed. It's much more a story about how do you think about this field in a computational way? How do you, for example, use computational language to do things within that field? And if you are using, for example, computational language to do things, you don't have to do a large amount of kind of sort of low-level programming to get to the point where, yes, you can do this thing in computational archaeology. In Wolfram Language, it might be a few lines of code. If you were to build it from low-level programming, it might be 3,000 lines of code, and that takes a lot of effort, and you have to know a lot of low-level software engineering to be able to do that. But I think a lot of the opportunity going forward is computational X for all X. And that really isn't something you need to learn, quotes, computer science to do. You need to learn computational thinking, and you need to be able to use computational tools and computational language and so on, but you don't need to be able to write low-level computer science kinds of programs to achieve those things. It's all about how do you think about these fields computationally? And I'm not sure it really even helps to say, well, I know how to write a for loop. Okay, great. Does it really help in analyzing, something about some archaeological artifact image processing kind of thing? You probably could write it with a for loop, but then you're building this huge tower of cruddy code, so to speak, to do it. Whereas the real point is to understand computationally, oh, we have to line these things up in this way, and we're thinking about these things as sort of computational entities in this way. And if you can express that directly, and that's kind of the power of computational language and the things we've built to do that, then that's how you should do it, rather than, oh, I've got to do a bunch of trade programming and write 3,000 lines of code to achieve this particular thing. So I would say that the greatest growth areas today are really computational X for all X, more so than doing essentially trade programming. And I would say that doing trade programming, the best way to get to do it well is just having experience doing it. As far as computational thinking is concerned, and being able to sort of contribute to computational X, knowing about X, if you want to contribute to computational X, is really worthwhile. And knowing kind of principles of computational thinking, which is more, I would say, the computational language story, and more kind of the concepts of computer science rather than the detailed experience in programming, that that seems to be a valuable thing. And sometimes what I see rather too often is people have learned low-level programming, and then they see our computational language and so on, and they're like, let me write a loop to do this and this and this. Well, that's just a stupid idea. It makes the code unreadable. It makes it hard to understand what's going on, and it isn't even as efficient for the computer. But yet, it's kind of like, but I was taught there's this way that computers work, and they go through and they make loops to do things. Well, yes, that's maybe how the hardware is built. But the great thing about software and so on is that we can build these layers that kind of adapt to the way that we humans think about things, which isn't in terms of the same kinds of operations that low-level raw computer hardware works on things. So I consider that a little bit of a pitch for the thing I've spent the last, 40 years or so working on, which is trying to build this layer of computational language that makes it possible to do computational thinking without doing sort of low-level computer science and low-level programming. Okay, let's see. There's a question here from Aaron. How do you manage technical debt? What advantages come from using Wolfram Language as an in-house code? How do you manage technical debt and things like Java code bases? Here's a great thing about Wolfram Language. We first released it in 1988 in the form of Mathematica, and the code that I wrote at that time in our language still runs today. This is one feature of both the fact that we've had sort of a consistent thread of innovation, people, organization, and so on through that period of time, that we've been able to maintain compatibility over the course of now more than a third of a century. That's really valuable. The things that, for example, when I wrote my New Kind of Science book, there's, every picture in that book was made with Wolfram Language and Mathematica code, and it still runs today. Some of that code is a bit cruddy relative to what one can do today, because some of it involves sort of idioms, which now are just named functions. Some of it involves going to more trouble than you would need to go to today because we've automated more stuff. And yes, that's something where it is, often desirable to go back and sort of make it cleaner, but not really necessary. It still runs just fine. When it comes to, well, let's see. We haven't had so much of an issue with kind of the whole legacy code kind of thing, partly because a lot of our system is written in Wolfram Language, which has remained compatible over a very long period of time. And because it is a language where sort of everything is built in, there's not this giant chain of dependencies and, oh, this library here might have changed and there's a whole domino effect of other libraries that are now not working, et cetera, et cetera, et cetera. That really just doesn't happen to us. So I can't really speak from personal experience in a lot in dealing with that. I think that our core kernel is written in a variant of C that we developed, and it's sort of increasingly in C++ now. We developed that variant of C because at the time C++ was just a preprocessor for C, and it really wasn't efficient enough for things that we wanted to do. I would say that we have a certain amount of things like Java code we wish we didn't. Typically, it's been kind of a cautionary tale of don't write things in languages that have sort of certain, complexity in their life cycle, so to speak. We've sort of generally tried to replace those kinds of things. I think that in terms of, so here's a principle that I found important. So for us, the functional design of things, and particularly when you're maintaining compatibility over the course of many decades, functional design is pretty important, and you have to get it right. Well, I would say we've done a really very good job at getting things right, but sometimes there are things where by the world evolves and people understand things differently, or sort of the algorithmic space evolves and there's more things you can do, or our thinking evolves and we realize one can do things in a sleeker, cleaner way. And so often the issue comes up, we've got this new way of doing something or this new thing we want to do, and we've got this existing way, and it looks like the new thing we want to do is incompatible with the existing way to do it. And so one thing that people tend to do is to say, oh my gosh, we can't do the new thing. Look, we've got the old thing, it's going to be incompatible. People are going to be confused, it's not going to work properly, et cetera, et cetera, et cetera. My principle has been always figure out how you want it to work. Just when you're thinking about the design, don't even think about the way it used to work. Just figure out how you want it to work. And the thing that I found is once you have that beautiful, clean, here's how it should work thing, it is usually, and essentially almost always, possible to build a bridge back to what you had before that is a compatible bridge to what you had before that says, well, that was the way of doing it before and that will still work, but there's this new sleeker way of doing it that's easier to understand and so on, and you kind of lead people into that way of doing things. And I think there's a tremendous tendency on the part of people who are deep in the weeds of implementation to say, no, we can't do that, it's not going to be, it's going to be such a mess relative to the things we already have. Now, in terms of technical debt and code and so on, there's what we've tended to do is, I don't know what the average longevity of code that we have is. It's probably 20 years or so. But what happens is that these big areas of our system where over time we collect a lot of, we'd like to be doing this and this and this. And then at some moment, there's enough new stuff that we can achieve that it's worthwhile to just go in and basically renovate that area and often rewrite a lot of things, make them more general, cleaner, more efficient perhaps. It doesn't seem to make sense. I mean, we often have to do a certain amount of patching of, there's a bug here, there's some extension that's needed here and so on. But for us, it's better to wait until there's really an accumulation of, one could take this whole area and make it better. And that's kind of the thing to do. Now, sometimes I would say that there are cases, and this can be true in some of our external code and so on, there are cases where you can put a beautiful modern wrapper around a piece of kind of cruddy old stuff. And really people are only going to interact with the wrapper. It doesn't really matter that there's weird sort of cruddy stuff underneath, so long as it keeps running and the bits keep, sort of the program keeps operating, it's sort of okay. Those things will often come and bite one. The bits will tend to rot in one way or another. But that's at least gets one quite a lot of mileage quite quickly. I mean, for example, at our company, we have a big project, actually, I believe a big piece of it is going live just today, a big project to rewrite our ERP system, our transaction processing system, our sort of business systems, the company rewriting it all in Wolfram Language code. It's been a long project. We are dealing with some very, I would say, pretty cruddy old style ERP systems, and we're replacing them with something that we've created that is based on sort of symbolic language ideas and so on. That's rather beautiful. But in that case, what's interesting about that case is that as we've gone through to do that, the biggest part of the issue has not been, can we make the code work? The biggest part of the issue has been, oh, we've got all these policies and procedures and this and that and the other that were sort of twisted to be the way they are because they had to be twisted because of the kind of cruddy old ERP system that we had. And so as we think about it, and then people don't really know anymore, why was it done that way? And people say, well, it doesn't really make any sense. Now, as we think about it, if we really dig in and think about it, it doesn't make any sense. Let's just rethink how it should be done. And then the code, and this is kind of for a language designer like me, it's kind of like, if it makes sense, it will be clean in the language that you write it in, if it's a well-designed language. And that's certainly what we found in this ERP effort, that when we can unscramble, well, what was it we really wanted to do? It turns out to be rather easy to implement. And I think that can be a big issue with legacy code bases, is that you say, well, I really want to modernize this, but you'll modernize it together with all the weird things that were done the way they were done because of the constraints that existed in that code base. And it requires a certain kind of thinking, and often the people who made the decisions for the original code base aren't around anymore. And so you're having to sort of rethink that based on kind of, well, what do we really want this to do? And it's important to realize that you do want to rethink the functional design at the point where you're sort of where you're renovating the code base, so to speak, rather than just saying, well, we just got to make it work the way it worked before because, well, that's the way it has to work. And often in a company, when you're dealing with, for example, business systems, there are many tentacles to that. I mean, there are many groups in the company that will be affected by changes in a core system like that. And each one, and it's a non-trivial project of going around and sort of making sure that you can sort of revise the policies and procedures in the same kind of way that you're also revising the underlying code. And often that's at least as difficult, if not more difficult, than dealing with the code itself. But I think it's a really worthwhile thing. And in a sense that can be, a really good functional design will typically make the code easy to write when it is written in a good language. Okay. Let's see. Golagaz asks, how do I cope with the stress of releasing new products? It's very hard to judge success beforehand. Do I have techniques to reduce that stress? Oh boy. Well, I think, yeah, you don't know what's going to happen. The first step is to actually get the product released. And I think that's the place where the most intensity usually goes in. And I think that whenever there's a really new innovative thing being delivered, it requires intensity to get it to happen. I've been doing this now for more than 40 years of releasing kind of innovative products and so on. And it never goes away. The intensity you need to really get a thing out that hasn't been done before, where you're doing something that's never been done before, it needs intensity. For many years, I've been working with many of the same people for several decades now in releasing versions of what's now Wolfram Language and so on. And for a long time, I used to say, will we ever have a calm release? I asked. Will we ever have a release where there isn't a whole bunch of last minute emergency gnashing of teeth, how did this fit together, et cetera, et cetera, et cetera. And a few years ago, I was finally asking that again, will we ever have a calm release? And by golly, that release was a calm release, even though no previous one had been. And I think the point is, after enough time, with enough procedures and enough kind of sort of framework for innovation, you can make these things be fairly calm. The other point is, when you're doing releases, incremental releases of a product, there's kind of how important is it that it makes this particular bus? And can it just, if that team falls behind, can they just take the next bus and go out on the next version? And that's typically a very, we've had the issues that come about there. If the buses are comparatively close at hand, let's say less than 6 months apart, then most teams won't be horrified, and most kind of market objectives won't be a horrifying thing. If you miss this bus, you have to go on the next bus. If the spread between releases gets to be 18 months, 2 years, it's a big deal. It's a lot happens to a team and to the world in that period of time. So it's a reason to try and push for more frequent releases. We're right now trying to do 2 releases per year. And because it puts a lot less pressure. Now, the thing that happens is you end up with a situation where you say, either we're going to have a schedule for releases, or we're going to say we're going to, insist on having certain features in the next release. And I have to say that I'm sometimes an offender in saying this next release just has to have such and such a feature. We cannot release another version without having this solved. And that always puts a lot of strain and pressure on the release process, because that may be a really hard thing to achieve. And it's something where we're saying we cannot release, even though we have schedules, and even though other teams have delivered what they've delivered, we cannot release without having this particular thing done. And yes, there's a lot of intensity around doing that. Now, the question of when you release into the market and does the market care or not, always a challenging thing to know, and something where I guess we've been fortunate enough mostly to not have, we're not betting the company on the next release type thing. It's something where, when you're building something and you really just have no idea, and it's your first product, and it's like you put a lot of resources into it, you've got lots of investment in it and so on. And, is it going to work in the marketplace? It can be really hard to tell. I would say, to me, the number one criterion is, do you yourself really believe in it? Do you use it yourself? Do you really, do you have that, I really care about this part? That, to me, is very important in whether it will succeed in the market. I don't know why. It's kind of a thing where sometimes I look at products and I say, by golly, this succeeded by virtue of the fact that the people who were originally introducing it to the market were so enthusiastic, the market had to pay attention to them. Even though the thing, well, it's kind of a weird thing, and I'm not sure why one would care. But people got so enthusiastic that the enthusiasm eventually kind of fed on itself, and that made the whole thing successful. But I think the bad case is you don't really quite believe in it yourself, and you're worried about, you think, well, I'm not sure this is really going to be useful. That's a bad sign. When you are really bought into it and like, this is fantastic, and if people out there don't care about it, well, it's their problem type thing. That's a much better place to be. But in terms of the intensity of actually doing a release, getting a product out there, I have to say, one of the things I used to be very afraid of, very concerned about, is, I can generate a lot of intensity in, we are going to get this out. This is what has to happen. We got to solve this problem. What's the next issue? What's the next, blocking issue? Let me, myself, as the CEO or whatever, dive in. And if there's something that's blocking us, I want to understand. I don't want some team to be telling me we're blocked for another however many weeks. And it's like, I'm not going to buy that. I want to see it with my own eyes and understand it myself. And often I can be helpful in actually solving the problem. But the thing that I always used to be concerned about is that, I would put so much intensity in this thing. We've got to get it out. Everybody's got to be working really hard to do this, that people would be just like, oh my gosh, I can't handle this. I'm ejecting, I'm out of here, 2 weeks before the release type thing. That, touch wood, really doesn't happen. It just doesn't happen. People are much more likely to kind of eject after the release comes out, after the intensity is over. I think for many people, it's kind of fun to be involved in this, can you finally make this thing happen? It's a sort of a team effort and everybody is pushing for it, and it's very intense, and it's kind of it's an interesting human experience, and it's very satisfying. And it's something where, yes, there's intensity, and it's like, you've got to put in lots of hours and so on. And if you're putting in hours just for the sake of putting in hours, then that's going to be a lose. But if you're putting in hours because there's just an intensity of things that have to get done and a deadline, I think people actually feel very energized by that. In fact, the much greater risk is when a project is finished and people are like, I put all this energy, we've got it finished. fantastic. And then it's like, what am I going to do now? And that's when people kind of are like, oh my gosh, I'm staring into this chasm. And that's when people quit and move on to the next thing. And it's not the time when there's sort of high intensity coming to the end, typically. And that's a thing for management where, when you come out of a big project, you have to know that there's this kind of decompression phase. And it's like, take those people and put them on another project that has intensity, or at least some degree of intensity. Don't let them sort of hang out in this chasm for too long, because that's really bad for everybody, and it's kind of not much less fun than being involved in this thing where everybody's climbing the mountain together type thing. So for me personally, for me, I suppose my own stress reduction method is don't just sit back and wait for other people to do things, actually get into action and do things yourself. I mean, for me, whenever I'm in a situation where it's like I'm just waiting for something, that can be stressful. But when I've got something that I can do to move that forward, and where sort of I feel like I'm contributing to it and I'm active in doing the thing, that for me, at least with my particular psychology, is vastly less stressful than the just wait and see what happens kind of mode. And I suppose that's when it comes to product releases, if it's like, okay, team, go and do this and tell me when it's done, you might be, biting your nails, wondering, are they going to get it done? Are they not going to get it done? Well, for me, at least, it's like, let's just dive in and see what the detailed issues are and work with everybody and, be part of the story, so to speak. And that way it's a lot less stressful than watching from the outside and just sort of hoping that things are going to happen correctly. Let's see. Dava is asking, if you were never allowed to use Wolfram language, what would I use? I would take whatever language I had and I would rebuild the features of Wolfram language that I need. Because, when I was working on, so I worked on a bunch of science in the 1980s using sort of earlier things that I had built and a lot of existing tools for doing sort of the computational side of the science. And then I wanted to work on my new kind of science that led to this big book called New Kind of Science that came out in 2002. And, I kind of did the calculation. I want to work on the science. I'm going to I need tools to work on the science. And I also knew that building Mathematica and so on was a useful thing. It was building both something useful for the world and something that would create an environment that I could do other things productively in and so on. But what I realized after sort of 5 years of really devoted to just building the software system, what I realized is, had I tried to do my new kind of science, which took a decade to write that book, had I tried to do that, having not already built these tools, it would have been not a decade, but more like 30, 40, 50 years to do the same kind of work. So in other words, the tool building effort, the effort to build the tools, even though it took 5 years, was still dramatically reduced the amount of time it took to actually do the project. So I think maybe it's what I would do if I didn't have Wolfram language as it is today, I would rebuild it because that would be, in order to do the other things I want to do, I need it. I mean, the things we've been doing with our physics project and the mathematics spin-off that we just did from the physics project and the other spin-offs that we have in all sorts of areas of molecular computing and biology and linguistics and economics and so on, all these things, they are on top of a big tower of both science and technology. I mean, our physics project would absolutely not have been doable without a lot of the things that we've built in Wolfram language over the past 3 decades. They were really critical to being able to do that physics project. And were I to be thinking about doing things, I would build the tooling and then do the thing that I have to do. And if the tooling that I built in Wolfram language, I think maybe the world doesn't appreciate it as much as it should, or as much as I think it should yet. But it's really something that is extremely valuable. It's a very tall platform, tall tower, and it's a little disappointing that I can now see this 40-something year span of what people have understood from things that I was doing like 40 years ago, and I can say that it's going to be 50 or 100 years before, at the current rate things are going, before it's like fully absorbed what we've done. Doesn't mean that people can't sort of grab artifacts from the future to today and give themselves and the world lots of mileage from being able to use artifacts from the future. But it's still something where the sort of the inexorable progress is on timescales of 50 to 100 years. But in any case, I would say I would end up building the tooling again. One of the great features of universal computation is, okay, you give me programming language X. It's still a universal language. It may not be, some of them are better languages than others in terms of their design, in my opinion. But in any of them, it's possible to build these sort of higher layers because that's the nature of universal computation. Let's see. Question here about, do I find that innovation is largely driven from within, or is it largely driven externally from users and so on? This is a question from Bill. I would say that for us, it is very predominantly driven from within. That is, because we are operating in this, we're really very far ahead of where sort of people expect us to be, so to speak. We don't really expect people to be like, there certainly are people, users of ours and so on, who absolutely understand the very leading edge of what we're doing. But it's something where, for the most part, the innovation comes from within. I would say that what can happen is people can say, you really should be doing X. And X just doesn't fit in with our current path of what we're doing. And sometimes people would say, you should be doing X. And a decade later, we realize, well, actually, now we really can do X. But back at the time when it was suggested, it was just not in the direction that we were going or that we had the sort of framework to be able to deal with. I think that, one of the things we've been doing, for me, probably, well, a very primary source of ideas for what we should be doing is my own use of our products myself, and things that I'm doing and people working with me and so on, using what we have, or our internal use within our company of sort of the dog fooding of our own products. Those are things that are great for driving innovation and driving sort of, we should think about it this way and so on. I would say that there's also kind of in the outside world, things which I'm sort of interested in, where I say, can we, how should we do something like this within our ecosystem? That's another good source of ideas. And yes, there are cases, plenty of cases, where people will say, I wish your product did this, this, and this. But I would say that is small compared to the internal push to innovate for us. It's not true for everybody. I mean, people will say, oh, you should listen to your customers to decide what you should do. I think that's a wimp out. As far as I'm concerned, at least in my way of building products and my way of trying to do innovation, you're leading. This is what you've signed up to do. If you are sort of doing energetic innovation, you are leading things, you are inventing ideas, you're sort of pulling the world forward, rather than the world is kind of chasing you to say, do this, do this, do this, do this. I mean, that to me is, if you don't have the ideas yourself, you don't know how to innovate yourself, then that's a place where, yes, you should, take the crowdsourced input all the time, and that's the place where you should learn what to do. Now, sometimes another thing that's important is you put something out there, and then you see how people use it, and you see how you use it yourself. And some things, well, you thought that was a good idea, but then you realize, I never use this, and I don't know anybody who uses this. Well, that was an idea that didn't work out very well. Or sometimes it's this thing, and it's kind of like, sometimes it's even very late in some, there's some giant tower you're building, and there's one feature of that giant tower And it's like, well, that's kind of a nice thing. We can now do that because it's part of this giant tower. You discover it's that one feature that's the thing everybody cares about. And yes, that's a very useful piece of feedback. And that's something you usually discover it yourself by actually using it, but you usually can't discover it in advance. I mean, with lots of experience, which, at this point I have, for example, sometimes you can have a pretty good, I think my success rate of figuring out sort of what will be of the big tower, what will be the kind of the little piece that's most popular. I don't know, maybe a little bit more than even odds of being able to predict that. Being able to predict, will the whole tower be useful? That is much more effective. But the particular thing, often I'll realize it after we've had it for a month or two. I'll realize, look, this is the really useful part of this. Like, for example, I tell a story about in the 1990s, we were building out our ability to do symbolic graphics and symbolically represent everything that was visually, visual interfaces and so on to our system. And what we thought was going to be sort of the important story of that was, people will be able to edit graphics and things like this. Just turned out that wasn't the important story. The important story was being able to programmatically create these kinds of things and to be able to interactively manipulate them programmatically rather than the by hand editing and so on, which didn't turn out to be that important. Okay, maybe one or two other questions and then I should wrap up and go. Let's see. Question here from Amusement Park. How do I see the current co-creation space and how can we bring benefits to smaller businesses with smaller budgets? I see lots of sort of incubators and, co-spaces of various kinds. And, I think there's lots of energy in places like that. And for me, often, kind of like, I know what I want to do, just leave me alone, I just want to do it. But I think there are a lot of people where there's a lot of energy generated by being around other people and having the possibility, if you're in some co-creation space and you've got some great idea and it's going to be this company, it's going to be really good, it doesn't work out, but you have been hanging out with all these people who are doing these other things, it's like you quickly attach yourself to somebody else's enterprise that from the co-space, so to speak. And that's a pretty good dynamic for all concerned. I think that my impression is that it's been but pretty successful models that are at some level kind of real estate plays of have a desk, rent a desk, be part of this community. That seems to work well for a lot of people. There are a lot of successful places where that's been done. I think that a thing that's interesting about companies and office spaces and things like that, for my company, back between about 1986, when the company started, and 1991, we had offices in this very kind of strange setup because it was a big, tall building that had basically been an apartment building. It was gradually being converted to offices. And so we had this utterly weird office setup where happened to be a circular building, but we had these little pie wedges of our space, and we were taking over more and more floors, and we were ending up with situations where there was 2 apartments on the floor and the rest of it was the QA department or something. And it was very weird, and it was very, in a sense, very it sort of seemed very, everything was kind of, there were wires on the floor, and it was just generally not sort of perfectly cleanly organized, so to speak. But it was very energetic. It was I think that was a time when our company had mostly pretty young people working at it, and it was a time of great energy. Then we moved to much nicer office space, and it was really interesting because it was so quiet. It was always noisy before. We moved to this new space. Maybe it had better acoustic, provisioning and so on, but it was just very quiet. And it was like, it was as if there wasn't really anybody there. And it was a different feeling. It was a differently productive kind of feeling. But I think that there are sort of these incubator spaces where it's like everybody's there and it's kind of there's a lot of energy, and that's good for people in certain kinds of people in certain kinds of stages of activities and so on. Different from the just leave me alone. I know what I want to do. I just have, it's just going to take me a year to do it. I just want to be left alone to do it type of situation. And I think, I have to say that because, I don't know what the future will hold for all of these co-working spaces and the whole sort of people in offices and so on. I know that, for example, for us, well, different parts of our company are doing it slightly differently, but the main group in the US, we're basically, it's like, well, if you're going to be in the office more than 3 days a week, we'll reserve a place for you. If not, come and populate the desk when you come in type thing. But if we're going to keep a space, you got to be here for a decent fraction of the time. And I think that will probably be, we'll see how that works out. I don't know how that will work out yet. It's early days for that kind of way of setting things up. But I think, as I say, this kind of energy of being around people, some people, it's important. Some stages of doing things, it's important. Others, it's like, just leave me alone. It's funny, in our company, we've had many, the same kind of basic office space for quite a long time. And it's kind of gone through these different waves. So first, everybody wanted an office. They wanted walls, they wanted an office. And then people said, no, that's not modern enough. We want these kind of whole cubicle-like things. And they wanted open space. And it kind of, to me, that looked very much like the pictures of the Industrial Revolution, of just a long row of desks and people working at these desks. Of course, unlike the Industrial Revolution, everybody has these fancy headphones and so on. So you're at least acoustically in a different environment, and you've got your big screen or whatever, and you're visually in a different environment. You could be anywhere, except there happen to be people around in your peripheral vision, but it's a little bit different. But then, over time, there have been these sort of waves of interest in kinds of different ways to set up office space. And I think now the current wave is, I don't want to be in the office at all. I've set up this wonderful nest for myself at home, and I don't know what it's going to take for the office to compete with the home nest, so to speak. That's going to be an interesting thing to see. All right, maybe one more. Okay, this is Cerise asks, what is the best way to fund a research project? Would you always have to artificially describe some midterm objective of your research, midterm future application of your research to sell a business plan to investors? This is a very interesting question. How should basic research be funded? Well, how should research be funded? I think, let's say, it is, first point to make is, most things I have done have been things where they get done because there is an objective, because there is some tangible objective. We're just going to do research in this direction without there being an objective. That is what happens in academia a lot. And it is something where I think one can be vastly more productive by having an objective. Now, that objective might be, I want to deliver a product. The objective might be, I want to, describe this problem that I've solved type thing. And investors want you to deliver a product, typically. And because that's how the money that goes in ends up coming back out again. So this thing about, I'm going to figure out some great result in basic research, for example, our physics project, or my work in metamathematics, those things, I don't think, it's a very interesting question, how those things should be funded in the world. When it's a question of, you have an objective you're going to, if you say, I'm going to do research, but there is no known objective, I'm always questionable. You know, I consider that questionable. If the objective is we want to figure out the fundamental theory of physics, the objective is we want to understand the fundamental laws of metamathematics and so on, those are objectives. They may not be objectives where some investor can say, gosh, I make a good return on investment from that, but they're objectives nevertheless. So now the question is, do you have an objective that is aligned with what your investor is interested in and what your investor is trying to achieve? The investor could be just in it to make money. They could be in it because they want something, they want to be involved in something cool that I don't know, let's say it's a cryptocurrency, and one thing that's important to them is just being able to say, look, we're doing exciting stuff. There can be cases there where there isn't, and then the same is true with large companies as well, that there can be cases where investing in something just because it's kind of cool is already an objective in itself. It doesn't necessarily have to have, and we're going to make this amount of money in this way, because it's kind of like the investment itself it's sort of like a marketing kind of thing. It brings attention to the organization or whatever that is doing it in a way that more than pays for whatever the cash that's put up for that investment. So that can be an example of something where you're not directly saying, I'm going to deliver this product and it's going to be this particular kind of thing. Now, when it comes to basic research, this is a problem I would love to know the solution to, because I do not know the solution. And we are getting ready to launch finally a kind of Wolfram Institute thing that will be concerned with doing essentially basic research. And the reason why I'm interested in doing that now, I've looked at it a number of times in the past, but now we kind of have to do it, because from this physics project, we've developed this formalism, this kind of multi-computational paradigm that is just incredibly fertile and is showing us things that are relevant for molecular biology, immunology, economics, linguistics, evolutionary biology, lots of different areas. And it's just a crazy thing that this formalism has sort of dropped in our lap in a sense, and is really powerful and valuable for all these things. But most of these things, I don't know what the product is that will come out of them. You know, the understanding of economics might lead to some kind of distributed modern blockchain, might lead one to be able to make some kind of hedge fund-like thing, I don't know. But my interest and objective in it is more the basic research of it. And I don't particularly want to have to distort it and say, for every one of these areas where we're doing sort of a common piece of basic research, oh, we're doing it because it's going to have this outcome that has a definite commercial result. And for me, you know, I've been funding some of this basic research myself, but the scale that it can be done at is beyond what I can, you know, really justify funding myself, or at some point, some scale, it's beyond what I could possibly fund myself or through our company and its operations and so on. So it certainly raised for me the question of just how can or should basic research be funded in the world today. And you know, the general principle of research is, basic research is, if you have a monopoly in a particular area, then by all means you should do basic research, because it will definitely be to your benefit in the future, because nobody else has kind of the distribution channel or the deployment channel for what's being done. And you know, for example, when the US, with the sort of largest economy in the world, it makes sense to fund basic research, because if the things you're getting from that basic research are things that benefit the economy, if you have the largest economy, you have the deployment channel for many of those kinds of things. And and for example, in our corner of the world, there are areas of kind of algorithmic computation where we have the kind of the best deployment channel. And so it makes sense, even if we're doing pure basic research in that area, it makes commercial sense to do it because we're the main beneficiaries of that. Now, I would say in these areas of sort of more basic science and so on, it's very challenging. It's very to see what the how that really works. And you know, there's philanthropy, and there's just, it should happen because people think it should happen, so to speak. That is an interesting channel. I don't know there's sort of challenges in that channel because everybody has a particular thing that is their kind of what they think is interesting, and it may or may not align with what is the thing one can efficiently do. And then there are more elaborate schemes. There's like, well, why don't you make a token? Why don't you, do the crypto thing and make a coin? And, I've been thinking about kind of the thought exercise. Okay, you're old Isaac Newton back in 1687, you're inventing calculus, and you think that this is really a cool thing. And over the next 3 centuries, it's going to make trillions of dollars are going to be made from the application of this thing that you've invented. But you're in 1687. What do you do? And in the case of your sort of in the world of sort of NFTs and tokens and so on, can you think about that in a reasonable way? I'm sort of reminded of the fact that Isaac Newton himself, late in his life, was involved in this effort, the British government's effort to move their sovereign debt obligations to the South Sea Company, which then sunk. And Isaac Newton made the mistake. He had invested a certain amount in the South Sea Company, which had dramatically risen because everybody knew that the future was this, as it turned out, rather in many ways very unsavory business of the South Sea Company that was that it was just going to zoom to the moon, so to speak. And he invested and he made a bunch of money and he sold out. And then it kept on zooming up and he invested again. And then he lost a whole bunch of money because, needless to say, it eventually sunk. But it's an interesting question. What could be done? And this is a problem I'm currently really thinking about because we're trying to think about our Wolfram Institute and what the right way to launch and fund that, given that one has a time frame where one's doing research, where one, it's not something where there's we're going to deliver something in 5 years. Now, it turned out in the physics project, even though I thought that was a 200-year to application kind of project, here we are less than 2 years later, and we've got a whole boatload of applications that are starting to be evident there. And I didn't expect that, and that's a sort of pleasant surprise. But I think that I would just like to say, in terms of the funding of research projects and applications and investors and so on, I'm a great believer in don't take people's money unless you can do something worthwhile with it, and unless you can, they may want to give you money for essentially marketing purposes rather than for pure investment purposes, but you should understand why they're giving you the money, so to speak. And if you take their money, you should expect to give them something valuable back. It never, it tends not to end well. I mean, in the US, for example, unlike some other countries, it's like people will just, they'll do one company, it'll fail, they'll do another company, it'll fail, and people will keep on investing in them. My own belief is that's not the way to do things, and that, you have to understand what do the people who are, for example, investing want to get out of it. And it isn't always necessarily a return on the investment. There can be other objectives in the investment. There can be strategic reasons to do the investment. It can be a large company that wants to understand the kind of thing you're working on and that wants to be involved, so to speak. It can be essentially a marketing purpose and so on. All right, I think we should wrap up here. I know I'm very late for a piece of my day job and I keep on getting reminders here. So thanks for keeping me distracted for a little while here. And always a pleasure to get me to think about some of these kinds of things. And thanks for joining me. See you.